Welcome back. In today's video, we want to find the energy and the average power of the signal x of n. The signal x of n has the limits of not the series, but the unit step function, which is 1 for n greater than or equal to 0, and 0 for n less than 0. In this case, we're going to take the sum at which I, or in this case, n, runs from 0 to infinity. We know that to calculate the sum of the initial series as the limit of a partial series sum, we therefore have to calculate the series sum. We somehow have to find an expression of the partial series sum in order to calculate. So we know that the sum is equal to the sum at which n runs from 0 to infinity, and we take that for the ratio or the geometric ratio, which in this case is 1/4. The reason why this is 1/4 is because, as always, we take the absolute value of the signal x of n square, because the signal might be complex. So in this case, x of n square, and in this case is going to be 1/4 to the n power. Thus, that is the limit at which n goes to infinity for this partial series sum, and that is equal to the limit at which n approaches infinity. Not erasing. Well, that is infinity, guys. And we break that down. We either can write the ratio, geometric ratio, 1/4 to the n, still is equal to 1 for n, or 4 minus n. So in this case, we see that 4 to the power 0 is 1. We're going to call that b, plus 1/4, 1 plus goes on to 1/4 to the power n. To evaluate this, but before we evaluate this, we can see that as n approaches infinity, the geometric series, the progression is decreasing. And now we need to find, in order to calculate this, we need to find a partial series, some kind of expression or a geometric progression to evaluate this. And this is S of n is equal to b1 times q to the power n. And in this case, q is going to be our geometric ratio, which is 1/4. Thus, q minus 1 all over q minus 1. And we can simplify that by knowing that b is going to equal 1. B is 1. 1/4 of 0 is equal to 1, and q is 1/4. So simplifying that, we see that b all over 1 minus q. In this case, b is 1. 1 minus 1/4. Thus, that is equal to 4/3. So that is 4 all over 3. Now we can take the limit at which n approaches infinity for S of n. And in this case, S of n is 4/3. And that is equal to 4/3. So the energy for this signal is finite, because we run the sum over a finite limit, which is 0 to positive infinity. If we take the sum from negative infinity to infinity, we should have infinite amount of energy. In this case, finite. So we have a finite amount of energy, which is equal to 4/3, and that is less than infinity, the first class of signals. We know that if the energy of the signal is less than infinity, then the average power is equal to, in this case, 0, based on our previous videos. If you want to run that, we can do that by saying the limit. In this case, we can just put 1 to n, and I think that's plus 1, plus 1. And we already evaluate this sum, which is equal to 4/3. And we know that as n approaches infinity, no matter how large, if this is infinity in the numerator and this approach infinity, it will equal to 1. In this case, we have 4 over 3 in the numerator, and 2 times infinity plus 1 is still infinity, and that approaches 0. And that is why the average power is equal to 0. Thanks again. I'll see you guys in the next video. Bye.